Welcome back to C++ with Miyoshi. I want to talk about 2D vectors today. So 2D vectors are very useful if you want to make a table. So like vectors, you still want all your data in with one variable name, and now you get rows and columns. So if I want to do something like this row, three rows and 5 columns of data, I could do that very simply with a 2D vector. And the way I do that is, again, I use pound include my vector, and then I do using namespace std. Remember, if you don't use that, you have to put std : in front of vector, and then I do vector with the triangular braces, and then I do vector again. It's kind of a strange notation the first time you do it, the first couple times you do it, but I do vector, vector, and then there's my data type inside the inside vector. Now I could do more dimensions of these, but two dimensions is good enough for all the ones that we're going to use. Probably for most of the things you'll do, especially if you're in a high school class. But I have vector, open triangular brace, vector, open triangular brace, int, my data type, whatever data type that happens to be. In this case, I'm using an int. And then I have closed triangular brace, closed triangular brace, and then I have my name of my variable. Now, or name of my vector, which is a variable. In this case, the first case, I'm going to do an assignment, and all I'm going to do here, I want to show you how you set off the different rows and columns. So the columns are just commas. The data separated by columns are commas. That's your columns of data. Now, you don't have to make it look like rows and columns, but I like to do that. Your rows then are curly braces separated by commas. So I have curly brace, then my data separated by commas, so those are my columns. And then I have the close the curly brace and comma, and then another set of curly braces, data, curly brace, comma, and then my last set, curly brace, data separated by commas, and a curly brace, and then a closed curly brace. And of course my semicolon at the end. So this, from curly brace to curly brace, that's my row. Curly brace to curly brace, that's my row. Curly brace to curly brace, that's my row. So those rows are numbered 0, 1, 2. And my columns are numbered 0, 1, 2, 3, 4. Now, I believe in C++ you can have what they call jagged vectors, or jagged 2D vectors. And that would just mean that maybe you got rid of a value there. They're useful to have jagged vectors, but I'm just going to most of the time use mine as all the way full. That means they all have the same length, same size horizontally in this case. Okay? Then here's another way. We have a 2D vector. I can initialize this 2D vector, and that's with a nested for loop. So this is really useful. You want to probably make sure you know how to do this, but I have a vector int, and I call it v2d, so vector 2d, and then I do a for loop, int r for row, I like to use row and column rather than x and y. So I do int r is 0, r less than 3, so I'm going to have 3 columns. Remember, if you start at 0 and you go to less than, this is the number of times you're going to do that, iterations you're going to do that for loop. And then r++. And then I make a vector. In this case, I'm just going to call it temp. Whatever data type this guy is, I need to make sure that's the same data type. So I'll make my vector temp, vector int temp, and then I'll do another for loop, for int c. So this is my columns. Again, if I start this at 0 and I do this less than, in this case 5, then I can go ahead and make that, this is my number of columns. Then of course C++, my curly brace. I've gotten used to putting curly braces at the end of my for loops and my if statements now, so sometimes you'll see me do that and sometimes you'll see me do the other way, where I have it down here. It saves a little space on the screen here too, but anyway. In this case, I'll do temp.pushback r times c. And if we go through this, and then what I'll do is, after that, I'll close my curly brace, and then I'll do v2d.pushback my temp. Temp is a vector. And notice that's just like here, right? So I'm pushing a vector into a vector, and that makes my 2D vector, okay? In this case, if I look at this, r times c, r is going from 0 to 3, or 0 to 2, and c is going from 0 to 4, and you can see that that's this guy here. Now, if I want to make something useful, maybe I want to make a multiplication table, and maybe I want to make that multiplication table from 1 to 12 or 1 to 13 or 1 to whatever. I could do something like this, right? I would make it square if I was going to do a multiplication table. But if I wanted to make it something like this, how might I change this guy right here? Well, if you think about it just a little bit, all I have to do, the only thing I'm really going to change, because these are the same size, right? 3 rows by 5 columns, 3 rows by 5 columns. They're the same that way. All I have to do is change one little thing. And that one little thing is actually, I want to start counting at 1. And I want to start counting at 1. So all I have to do is that. Put my parentheses in there so I could change my order of operations. But I just add 1 to R and add 1 to C. And then I could do that right away. Now, the other way you could do that is you could change this to R. You could change the R to 1 and C to 1 and make that less than equal, less than equal. That would work as well. Without that, you only do one or the other. But I tend to like to do this because I like to count from 0 because I know that that's the way my array works, or my vector works. Now, if I was going to output this, you definitely want to start with R is 0 and C is 0 when you output it. And again, instead of the 3, I would put vector or v2d.size. Actually, I would put v2d. Actually, yeah, let's make sure we do that. If I'm going to output that, I would do v2d.size. I'll do v2d.size if I'm going to output this now. So this would be, instead of this, I'm maybe just going to do a printf instead. And then this guy here would be v2d dot or square bracket r dot size. That would be the way you want to make sure that you, in case this was jagged, right? Jagged? Did I say jagged, ragged? I can't remember which one it is. But if they didn't all have the same number of rows or columns in their rows, I could do v2d r dot size, and that would make sure that I get the whole column there. And instead of doing this guy, I would do something like a printf or something like that. Would work out really well there. So again, if I'm going to output, or I'm going to do something once the vector is created, then I want to do v2d.size. That tells me the number of rows, and then I do v2d sub r dot size, or you could do the dot at with the parentheses and the r inside there, dot size, and that would give you the number of columns. Okay, so 2D vectors, very useful, especially when you're making tables. And again, the tables don't have to be just integers. They could be whatever data type you can put in there, which is any data type, any class, any object that you create, any structure that you create, anything, any data type you can use anywhere in your program, you can use in a vector. So thanks for tuning in. We'll see you next time on C++ with Miyoshi.